Yes, hello everyone. Welcome back to the world of mathematics. Don't forget, we started our work on the whole number where we look at the in and out of whole number. Now we have the last aspect of whole number, which is the theory behind whole number. So quickly, the first one we look at is counting. Counting is just the normal counting, right? 0, 1, 2, 3, 4, like that. So we have counting. And you see counting means start from 0, 1, 2, 3, and then you can continue. Easy, right? So the second theory is even numbers. So what is even numbers? Even numbers are numbers that is divisible by 2. That is divisible by 2. So we start count, and of course it's from the counting. So if this is, let's write more: 4, 5, 6, 7, 8, 9, 10. Okay, now from here we can write out our even numbers. So we have 0, 2, 4, 6, 8, 10, and so on. So these are the numbers that can divide by 2. So this is 0, this is 2, add 2, add 2, add 2, add 2, and continue. And the odd numbers, see, odd numbers are numbers that are not even numbers. You see? So the numbers that are not even numbers are what? If 0 is even number, of course 1 is not even, 2 is even, so we have 3, we have 5, 7, 9, 11, and so on. So you see that the combination of even numbers and odd numbers give us counting, right? Good, good. So let's look at some properties of even and odd numbers. Let us look at it. Let us, odd number plus odd numbers. What do you produce? Let's see. What is even odd number? Let's take any odd number. 3. Take any another odd number. 7. Sum them together. What do we have? 10. And 10 is what? Even number. So which means odd plus odd is even. Odd plus odd is even. What if you have even plus odd? Even plus odd is odd. Even plus odd is odd. So we check it. Let's check it. Tell me any even numbers. 4. Any odd numbers? 11. So 4 plus 11 is what? 15. And 15 is what? Is odd numbers. So which means even number plus odd numbers is odd. And of course, odd plus even is odd. Right? This is just like we say rice and beans. Beans and rice. Everything go to the stomach. Right? So anyone you like, you eat first. It's okay. For addition. In subtraction, it doesn't work yet. Sometimes. Okay. What of even plus even? Even number plus even number is always even numbers. Yes, let's check. 2, 6 is what? 8. So under the addition, we have these properties. What of subtraction? Subtraction. Odd minus odd. What does it give? What does it give? At this level, since it's odd number, make sure that the first one is bigger than the second one. At this level, we will work on integers very soon. So let's say odd numbers is 7. Another odd number that is not up to this is 5. So minus it is what? 2. So which means odd minus odd give us even. Interesting. So odd minus odd give us even. Okay, what's even minus even? Even minus even give us what? Let's check it. Even is 8, another even is 4. Minus 8 minus 4 is what? 4. So which means even plus even, even minus even is even. What if we have odd? Even minus odd. What do we get? It should be odd, right? Let's check it. 12 is even. 2 is not odd. 3 is odd. So minus it, what do we have? 9. And 9 is what? Odd. As predicted. As predicted. Okay. We can play around like this. A lot of multiplication. Property under multiplication. What is odd times odd? Odd times odd is what? Or to guess. Let us use number to check. Let's say we have 5. It's odd. Times 3 is odd. 5 times 3 is what? 15. Surprisingly, odd times odd is giving us odd. Does it work in all cases? Let us try another odd number. Let us try another odd number. Let's say 11 times 7. 11 times 7 is what? 77. 77 is odd. Oh, so odd times odd is odd. Wonderful. Wonderful. What of even times even? Even number times even number. You should give us even, right? Okay, let's check it. Let's say we have 2 as even. We have 4 as even. 6. So even times even is even. Even times even is even numbers. 2 times 4 is what? It's 8. Wonderful. 2 times 4 is 8. Not plus. Not plus. Okay, what of even times odd? Even times odd. Predict. It should give us odd, right? Let's check. Let's check. Always check. Always check. It should give us, you say if, you say odd, you say even. Let's check with numbers. Let's say we have 2 and we have 3. 3 times 2 give us 6. You are right, but you are wrong, of course, unfortunately. So it gives us even number. Okay, let's try another number. Maybe this one is just lucky, right? Let's try 6 times 5. 6 times 5 is what? It's 30. It's 30. And 30 is even. You see how we are playing around with this? We can also do the same with division. With division. We can do the same with division. Let's say, what is odd divided by odd? So let's pick a number. 15 is odd. 3 is odd. So 15 by 3, meaning 15 divided by 3, which is 5. Oh, odd divided by odd is odd. Odd divided by odd is odd. Okay. What of even? Even divided by even number. What is it? Give us even number. 4 divided by 2 is 2. Oh, even is even. Rasasi. Razaze. Razaze. Even is even. Even is even. What of even divided by odd? Let's see, 12. Odd is 3. It was 4. Even divided by odd is even. Wow. 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 Okay. I think this is nice. It's nice. Let's move further. Let's move further. Now we have looked at counting, even, odd, and we are playing around with them. So let's look at another one. So let's look at more example. We have count in twos, right? Skipping 2. What to skip 3? Skip 5. Skip 7. Skip 8. So these are possible things. So we're going to skip to the example. Let's we got 3, 6, 9, 12, and so on, right? What about 5? 5 is what? 5, 10, 15, and so on. You can also count in 10, right? Any number is possible to skip. 10, 20, 30, 40, and so on. These are mental sets. You can just multiply, just write the number, add it, add. This is just a summary, is it? Multiplies of odd numbers. So if you count in ones, which is what you have done, 1, 2, 3, 4, 5, 6, 7. Counting in twos, 2, 4, 6. Counting in threes, counting in 4, counting in 5, counting in 6, 7, 8, 9, 10, 11, 12. So this is the summary. So that's what we do. So we just first question. Determine whether each of the following is a multiple of 2. It's a multiple of 2. First one is 4, 8, 9. To check if it's multiple of 2. What are the multiple of 2 from this kind of number? Multiple of 2 is 0, 2, 4, 6, and 8. Right? Now, what is the last digit number? The last digit number is 2. Can 2 go in 9 without remainder? It's not possible. It's not possible. So which means this number is not a multiple. 2 can go there, no problem. 2 can go there, no problem. But 2 cannot go to the last number. If this guy is inside, this is outside, it's still manageable. But because the last number is 8, the last digit is 9, which is not under the multiple of 2, it's not possible. What of the second one? 3, 7, 1, 4. We don't even care about this. Check the last number. Can 2 goes in 4? Answer is yes, because it's one of the party. So if it can go, it means this guy is yes. That is 3,714 is a multiple. But you have to be careful. Let us check some property. In 2 it's possible, in 3, in 4. But in some numbers, it's not that too easy. So let's check some properties. Okay? Are you tired? Are you tired? I will never be tired. So, divisibility test. We have done divided by 2, right? Divisible by 2. We have to consider the multiple of 2's, right? Which is 0, 2, 4, 6, or 8. This one we have done, right? So the last number must contain this. But what of if it's divisible by 3? Divisible by 3 is not the same. It's not the same. What we have to do in divisibility by 3 is very easy. If we are given, for example, 1, 4, 1, we want to check if 3 is divisible by this guy. What we have to do is add each of the digit number. 1 plus 4 plus 1, which is what? 6. Can 3 goes in 6? Yes. This is how you know divisibility. It's very important. So which means if you divide this here by 3, it will go without any remainder. Should we try it? Let's try it. Using long division. Long calculator. Can you draw the calculator? Can 3 goes in 1? No. Can 3 go in 14? Yes. How many times? 4 times. Good. 4 times. So when you divide, you multiply, right? That is 12. And you minus. So this 4 minus 2 is what? 2. Drop 1. How many times 2 goes in 21? 7. 7 times 3, 21. You see? It goes. What if we have another number? 2, 4, 3. Can 3 goes here? We don't know. Let me make it more difficult. 1. Can 3 goes here? We don't know. What you have to do? Add each of the number. So we have 2 plus 4 plus 3 plus 1. What is the sum? 6, 9, 10. Can 3 divide 10? It's not possible. It means that when you use long division method, you will surely get remainder. So we do it. Let's try it. Let's try it. Let's try it. 2, 4, 3, 1. Divide by 3. Now 3 goes into, no. In 23? Yes. Sorry. In 24? Yes. How many times? 8 times. Multiply it. We have 24. This is gone. So drop 1. Drop 3. Can 3 goes in 3? Yes. 1. Multiply. We have 3. It's finished. Drop 1. Can 3 goes in 1? Not possible. You can see? It's not divisible by 3. This is the method. So divisible by 3, add each of the digits number. Good. Now, divisible by 4. We have done 2. We have done 3. Now 4. How do we know a number can be divided by 4 without any remainder? How? The last 2 digits of the number must be able to divide by 4 without, 4 must be able to divide it without any remainder. For example, let's say we have 1, 1, 5, 2, 4. All these 3 is not big problem. The main thing is the last 2 numbers. Can 2 go and 4 goes in 24? Yes. It means that this guy must be able to divisible by 4. So to check it, you know the method. Use your long division method. Check it, and you will see that the result you will get is 2881. Try it. But assuming 4 cannot go in the last 2 numbers, it means it's not divisible by 4. Please take note. Divisible by 2, it must be 0, 2, 6, 0, 2, 4, 6, 8. Divisible by 3, a sum of each digit must be able to divide 3. 4, the last 2 digits must be able to divide by. Now, divisible by 5. If the last number of the digit is 0 or is 5, it means it's divisible by 5. Let's take an example. Let's say we have 120. Can 5 divide this? Since 0 is the last number, yes. No matter what comes after and before, it's not our business. Once 0 is the last number, it means that 5 can go. Another example is, let's say we have 7, 9, 8, 1, 5. Since 5 is the last number, it means it's divisible by 5. But if 1 or 2 or 3 is the number, it's not divisible. Divisible means no remainder. Okay? Divisibility by 6 or of 6. If 2 divisible by 2 and divisible by 3 is satisfied, it means by 6 it's easy. Because the product of 2 and 3 is 6. So if this condition is old, it means that the third condition, that the divisible by 6 is good. Okay? Nice. I think it's enough for divisibility. Just for you to know when you want to divide, that this guy will not equal to remainder, that you don't want to remainder of the number.